Aluminum threads are vulnerable to stripping. Time-Sert is our chosen repair method for this aluminum repair. This oil filter cover is periodically removed for service, and this has put wear on the threads. The 4 threads in question are blind holes and measured carefully. The long bolt threads go all the way into the engine case, and they are not susceptible to wear. For the blind holes just over 18 millimeters length, a 12 millimeter insert is chosen. This will allow the insert driver to pass through the threads, securing the insert to the threads. The bolt thread pitch in this case is 1.0 millimeter on a 6 millimeter stud size. Note that the casting bosses around these blind holes are narrow margins, which makes this type of insert even more valuable. This T-handled thread repair kit was purchased for 6 millimeter stud size with a 1.0 pitch. This is precision tooling. The T-handled tap tool is not provided with the kit and is used here to turn the drill that is part of the kit. This is aluminum and cuts easily. Clean the drill bit after drilling each hole. Force is applied evenly and great care is taken to keep the drill on center. This aluminum will be replaced with a stainless steel high tensile strength insert. The drill has removed approximately 18 millimeters of blind hole threads. This unique counterbore tool is for setting the depth for the shoulder of the inserts. This is part of the Time-Sert kit. Keeping the tool straight is critical. Driving into the metal is necessary to get adequate depth for these insert seats. The T-handle provides the necessary care. Be certain to use a shop vacuum to vacuum away all debris between cuts. Keep the tooling clean. The tap guide provided for this tap is essential. Press the tap guide firmly against the shoulder of the metal. I use spray aerosol, carburetor, and choke cleaner to flush all debris out of these holes. The oiling system is kept spotlessly clean. This is a 12 millimeter by 6 millimeter and 1.0 pitch insert. Key to installing the insert is the Time-Sert special driver oil. Make sure that the counterbore seats are deep enough. The inserts lock in place, so you only have one chance to get this right. Coat the inner and outer threads of the insert with the driver oil. Rotate the insert without any bind. Make sure there is no resistance right up to the point that the driver starts pressing against the bottom threads of the insert. This locks the insert in place. When the insert is firmly against the seat, it should have its head slightly below the surface of the metal. The driver tool continues through the insert and sets the seat firmly. The driver tool must pass through the insert completely in order to form and lock the lower threads of the insert against the aluminum threads. The upgrade of these threads around the oil filter cover not only reinforces the cover threads, but also saves over $200 in the cost of a new case. The oil filter cover will fit flushly against the case and not interfere with the heads of the inserts. The heads of the inserts were seated firmly against the case bores before the driver went through the insert. The factory torque setting on these bolts is 9 foot-pounds, which I believe is too much. I elected to set these bolts to 84 inch-pounds. This is 7 foot-pounds. These upgrade inserts now provide high tensile strength stainless steel threads and a permanent repair for this cover.